Hello students, welcome to the chapter Coordination Compounds. Let us continue our discussion with denticity. Now as we know that the ligands they have been classified on the basis of denticity into various categories. Let us begin with the next category, that is monodentate neutral ligands. And here you have the list of the unidentate or the monodentate ligands which are neutral in nature with their name, the formula and the name which is given in the complex. We are already done with this list in the prior modules. Let us start with the first one, that is ammonia. The formula is NH3. The name given is amine with double M. If it is present with any alkyl or aryl group, then we use a single M. The next one is water. Again, it forms only one bond. The second one is nitric oxide. Then we have carbon monoxide. The next one is thiocarbonyl, that is CS. The next is phosphine, PH3. The next is triphenylphosphine, and the next is thiourea. So if we see, these are all monodentate neutral ligands. That means they are neutral in nature and they are forming one coordinate bond with the metal atom. Now let us look at the polydentate neutral ligands, that means which are forming more than one coordinate bond, and the list is as follows. The first category in the polydentate is bidentate ligands, that means those ligands which are neutral in nature and they form two coordinate bonds. Let us look at the name, the formula and the name which is given in the complex. The first one is ethylene diamine, represented as EN. So here if you see, you have CH2, that is ethylene, and we have 2 NH2, so this becomes diamine, so the name given is ethylene diamine. If you observe here, the spelling contains only one M. Why? Because it is connected to an alkyl or the aryl group, which is ethylene here. The next example is 2,2-dipyridyl, and this is the formula of 2,2-dipyridyl, and the name which is given in the complex is dipyridyl itself. If you observe here, in the first case there are 2 nitrogen, that means there are 2 donor groups, so it becomes a bidentate ligand. Even in the case of dipyridyl, if you see there are 2 nitrogen atoms which is forming 2 coordinate bonds, that means again it is a bidentate ligand. The third one is orthophenanthroline, and here comes the structure. Again if you see, we have 2 nitrogen, 2 donor atoms, that means 2 coordinate bonds, and of course it is again a bidentate ligand. The name given is phenanthroline. Moving ahead to the next category, that is polydentate ligands, which is tridentate this time. That means 3 coordinate bonds will be formed. The example taken here is diethylene trimine. So here is a structure. Let us look at the donor atoms. If you observe, we have 3 nitrogen here, so they form 3 coordinate bonds. We have CH2, ethylene, we have 2 CH2, so it becomes diethylene, and 3 nitrogen, so triamine. As it is connected to ethylene, so the spelling of amine will contain only one M, so the name becomes diethylene triamine. Moving on to the next category, which is tetradentate in nature. That means they will be forming 4 coordinate bonds with a metal atom. And here you have the name, the formula and the name which is given in the complex. The example is triethylene tetramine. We have triethylene here, that means we will have 3 CH2 groups, 1, 2 and the third one. So triethylene is done. Then you have tetraamine, that means there will be 4 nitrogen donor atoms. So if you observe here, we have 4 nitrogen donor atoms. The name given in the complex is triethylene tetraamine itself. In this case, we are not putting any suffix O here because they are neutral in nature. The suffix O is utilized only when they have a charge of negative on them. That's all for this module. Thank you.